Quantum Lean's about indirectly eliminating waste, and it's by concentrating on and minimizing the time that a product spends on the shop floor. What we have found is that this approach is very simple, but it's also a way to comprehensively improve an operation. You get a really complete improvement when you do it.
Today, I'm excited to welcome Sean Fields and Michael Saunders to the show. Now, Sean and Michael have recently released a book called Quantum Lean, and basically what they've come up with over the years of practicing lean is what we would call maybe a slightly simplified approach to value stream mapping. Now, they have some different terms for it, but they've basically try to focus their lean efforts on focusing on the product and making sure that we just really reduce the lead time or the amount of time the product is even being worked on. So if it's not being worked on because we're producing it so much faster, well then there's not going to be any waste, right? But I had a lot of questions. I'll be honest with you. This was one of those episodes to where I was kind of scratching my head a little bit about, wait, aren't we saying the same things? You're just saying it with different terms. And so I kind of probed them pretty hard, as you'll hear. And but in the end, I think, as I say towards the end of the podcast, I think we're all, we're saying the same thing with just slightly different terms, but we're all on the same team. Maybe we just all have a slightly different playbook. But I really appreciated Michael and Sean's excitement for their approach and how they're trying to help their clients. So yeah, good stuff. Go check out the book if you're interested. Again, it's called Quantum Lean, and yeah, we'll put a link to that in the show notes. So this is going to be over at gembapodcast.com. This is episode 341. Again, gembapodcast.com. Look for episode 341. Okay, enough from me. Let's get to the show. All right, Sean and Michael, welcome to the show. How are you guys doing?
Doing great.
All right.
Thank you. Doing well. Doing very well.
All right. Well, thanks for coming on to the show. And I'm excited to, it's always fun talking to two different people, have two different perspectives. I feel like two podcasts in one, right? So
extra value we're trying to bring. Yeah.
That's it. Well, before we, towards the beginning of each show, guys, we like to have our guests, or in this case, guest in plural, share a quote. So Michael, do you have one that you want to open up with?
Yes, I like to refer to a quote from Albert Einstein. It says, "The world we have created is a product of our thinking. It cannot be changed without change in our thinking," which is very, very to the point when it comes to organizational improvement and changes that cause into or result into better way of running the business. To me, this is just telling you the heart of the matter.
Nice. I like it. Sean, do you have one?
Yeah, one of my favorite, my favorite quote regarding lean, it's from Henry Ford. And a while back, he said, "The longer an article is in the process of manufacture, the greater is its ultimate cost." And one reason I like it, I just like it. But number two, this is really I'd say a foundational quote to the whole idea behind quantum lean. And I know we'll talk about that more, but to me, this quote really just underscores the whole thing.
Nice. Very good. Very good. So before we get in, I want to ask you both to maybe share just a quick story on your personal backgrounds. But I wanted to mention that there's another group out there. There's a Quantum Lean website. I believe it's a Canadian company. And you guys are not affiliated with them. Is that correct?
That is correct.
Yeah. I Googled it and those guys jumped up. Looks like they do some interesting tours and so forth. So like an interesting group. So maybe we'll have them on the podcast one day, but, so why don't we jump in, guys, and just hear a little bit about your personal backgrounds and how you first got involved in continuous improvement. So, Sean or Michael, one of you can just maybe, take a turn here.
Okay, yeah, I guess I can start. My background, and there's a point in our background where Michael and I converge, and we start working together quite a bit. But my background is in manufacturing, and I've worked in both mass production and a whole lot in custom manufacturing. And a lot of that was done in a region of Texas that's called West Texas.
Mm-hmm.
And during that time, what I was finding when I was doing, things to try to improve production processes is, where lean is valid in a custom type environment. What happens is the way a lot of people explain it and the way a lot of people formulate it is that it's not very user friendly for that type of environment. And so, in the process of doing improvements, I ran into these challenges of trying to adapt that. And that was part of how, quantum lean came about. I mean, Michael had his own experiences
Mm-hmm.
when doing this, but my experiences trying to make this really work in a custom environment was what really helped bring it about. And the other piece is that, for people who aren't familiar with West Texas, it's a very unique culture, in my opinion, because I've been in 48 states and I've been in other countries. And to me, West Texas is really very different in a good way. I was raised in West Texas, so it's not like I'm, saying this in any kind of knock. But the thing about it is it's a very bottom line type culture and also very down to earth type culture. So you have to make things make sense to people in a very common sense way. And so that also was a piece of what kind of led to the creation of quantum lean as well.
Mm-hmm.
And so my background overall, I've got like over 30 years of experience working with like industries like I say, appliance manufacturing, oil field equipment manufacturing, and also food processing.
Thank you, Sean. I have a little bit of a more involved background in business. I came to the United States in 1984, and first thing was I began to learn English. And where I came from, when I was growing up, child labor was very much promoted in the society I lived in. So from very young age, my dad put me in learning different things, including welding. When I was 6 years old, I was apprentice to a welder, master welder, and I started getting the foundation of how manufacturing really is all about from very young age. Before I came here, by then I had very, very good success building 2 companies with several partners. When the last business I was in before I came to the United States I was making air filters for different cars. That was very successful. I learned quite a bit again on assembly type line manufacturing. But I came here, I went straight to school, and I learned quite a bit of different things. My bachelor's degree background was in biochemistry. I ended up building a food company, which resulted in 3 different organizations at the end. In around 1997, I was able to get out of them and sell them out. And then I didn't know what I was doing at the time, so I went to graduate school. And when I went to graduate school, the basis for that was I didn't understand processes. So when I went back to school, I converted from biochemistry background to engineering. So I went to industrial and systems engineering, and I was able to have my master's and PhD on that. And when I was looking into process improvement with different disciplines, obviously having scholastic background in systems and engineering, you end up learning about quality systems and quality movement. When I realized a lot of scholars talk about quality, talk about system improvement, but hardly few of them really tell you the story to apply to actual real world system. And along with that, you learn lean. And when you get into lean system, which was introduced in early 80s in the United States, I started diving into it and learning more about it. So to try to apply the systems or packages which were introduced in 80s and 90s, late 80s and early 90s to small businesses, particularly custom shops, it just wasn't working. So during that time, after I graduated, I took a professorship. I became a faculty in Michigan in Kettering University, formerly GMI. And when I was in GMI, I was actually pushing this lean system. I soon realized the way the lean is presented and people who like to use that and apply it really don't get the concept. The concept is not just trying to superficially mimic ourselves as Japanese companies do with just 5S implementation. It's not really what it is about. It's about the heart of the matter that quality systems always pointed out, and that's the product. So I started working with outside companies in Michigan, and I started consulting my 3 months of summer with different companies. And as I was practicing what I was learning, I was realizing that process focus has to really end up to the outcome of the process. That is the main focus, which we call products. So if you really want to implement lean, you need to look into the outcome and see what does lean system do to the outcome. If you're going to have faster, better, cheaper outcome, that's beautiful. Whereas trying to focus on the resources that got together and made the process for the product to come out, and focusing on those resources and being obsessed with those resources was a huge problem for me. In 2004, when we joined together, 2005, I believe, when we joined together, independently, we had concluded that, and we started talking about the early stages of, hey, we need to validate what we are talking about in different industries. And as a result of our validation, if it works out, maybe we can write something about it. So it took us better of 12 years to validate it with number of companies in variety of different industries. We started validating our ideas together. And as a result of all of these validations and confirmations in actual practical world of manufacturing, we came up with the book, Quantum Lean.
Okay, well, very good. So you've mentioned the term quantum lean several times now. Both of you have. So let's just talk a little bit. Give us a quick definition. Like, what is quantum lean in your opinions?
Well, in my book, quantum lean is a simplified approach to lean. Like, what I would say is a lot of times there's a tendency where people want to focus on the 7 wastes. For example, like excess motion or inventory, and they want to do this directly. And the difference in quantum lean is that quantum lean's about indirectly eliminating waste, and it's by concentrating on and minimizing the time that a product spends on the shop floor. And like what we have found is that this approach is very simple, but it's also a way to comprehensively improve an operation. You get a really complete improvement when you do it. Mm-hmm. And if I were going to draw an analogy to it, I'd say it's similar to what the Allies did in World War II, because at the time they could have targeted all kinds of military assets, communications, military bases, production facilities. But one of the big priorities for the Allies is that they focused on ball bearing plants. Because the basic idea is if you eliminate that one part, an entire war machine just grinds to a halt. It was a real simple approach to just, defeating your enemy. It was killing many birds with one stone. And basically, quantum lean operates on that idea that for waste to exist, time has to exist. Mm-hmm. And if you eliminate the product time on the floor, waste has nowhere to hide. And so that's the essential idea.
I got it. So like in my mind, I'm trying to think through just like a basic manufacturing scenario back from my manufacturing days when we were essentially trying to reduce increase throughput, reduce lead time, however you want to call it. Oftentimes we would identify waste and then we reduce that waste and then we were then going faster. So it's sort of, so talk us through that, so I don't know, the classic example, the machinist has running a machine and all of a sudden they have to go get a part, but the part's across the factory. So they have to walk to go get the part and then walk back. So that obviously is a lot of wasted time. If we remove that, the need to walk, to get those parts, then obviously you're going to increase your throughput. Is that kind of what you're saying or are you saying something else?
I think you have a great point, Ron. That makes sense. And let's take that machine. It's a little bit in a different view. Let's say a welder. A welder is supposed to be welding several pieces of metal. Mm-hmm. And then he starts welding the pieces. And suddenly he realizes he needs a part or he needs something that it's not there. Mm-hmm. So he stops and clocks out and goes out and comes back after 15, 20 minutes and clocks back in and welding. That's similarly what you're talking about.
Mm-hmm.
See, when we talk about focus on resources versus focus on product, that's the exact point we are trying to make. The obsession traditionally in management has been watching these resources and trying to find out what is happening to the resource. How can we improve and make more productive resources? So when a welder clocks out and goes out and comes back and clocks back into, or machinist clocks back into machine, we are trying to reduce that time and minimize and make it faster. But we are not talking about while he is gone, what's happening to the part. Our focus is on the part. We really don't focus on machinists, welders, on any other resources, on appliances or anything like that, or utilities and whatnot. We focus on the piece of the material that the resource is working on. The moment resource stops working on it, what is happening to that particular product? That product is still in existence of the time. It is collecting time. So the longer that product stays in the process of manufacture, the more it's going to accumulate its cost. This is the very quote that Sean gave you from Henry Ford. Over 100 years ago, he recognized that. Mm-hmm. Henry Ford was a master at that. And that's what we are trying to really focus on. Go back to brass tacks. Whatever the resource is doing really makes not much of a difference to try to manage their time. What makes a difference is to try to manage the product's time. That's where Quantum Lean looks at lean system in a little bit different way.
If I could interject, and I figure you visualize it very well, Ron, but depending on our audience, a story I like to tell to make this point is I like to draw an analogy to a movie called Castaway that starred Tom Hanks. Do you recall that movie, Ron? Or
which one is it again? Say it again.
It was a movie called Castaway, and it starred Tom Hanks as a FedEx employee.
Yeah. Wilson.
And just to give
Wilson.
The audience, Wilson. Yeah, exactly. Wilson. Yeah, that's exactly right. But in that movie, and just to get the audience up to speed in case they haven't watched it, is the Tom Hanks works for FedEx, and he's kind of a process improvement guy. And so this movie kind of spoke to my inner lean practitioner. But to me, one of the scenes that really embodies the concept of quantum lean is at the very beginning of the movie, Tom Hanks goes into a FedEx facility in Russia, and he has a kid hand him a package, and he opens that package and he pulls out a clock. And what that clock was saying was how long was this package in the process of delivery? And at the time, if I'm recalling correctly, it said something like 72 hours on the clock. And in a 24-hour operation like FedEx, that's obviously not good. But the point being is that quantum lean, when we're looking at time, it's put a timer on the product and then let that timer just run as the product is, like migrating through fulfillment. And once it's ready to ship, what would the clock say? Yeah. Because in our mind, whatever that clock says is the best barometer you've got for what kind of operation you have. I'm
with you. So, I mean, we call it production lead time in classic value stream mapping terms, right? So stamp your initials on the raw material at the very beginning, and how long does it take for that raw material to come out the other end? I guess what I'm still a little confused on, you're mentioning earlier about, I don't know, I'm just trying to understand, because I know many of my listeners are probably scratching their head a little bit too, is in order to reduce the lead time through any value stream or whatever term you want to call it, oftentimes there's incredible amounts of waste built into it, whether it's, communication, whether it's poor product design, right? We have a very bad product design that causes us to have to do, excess work when, why do you even need to do that, right? So that's where value engineering and different things like that come in. But at the end of the day, if we do have manual work being done on the widget at production part process A, let's just call it that, and the operator or the machine or whatever isn't working to their full potential, whether it's through defects or whether it's through poor programming, or whether it's through poor fixturing, or it takes us 2 hours to do a changeover. This is all waste. And in order to increase throughput, we're going to have to attack that waste. So that's where I guess I'm still trying to understand how what's the difference here?
Well, I think I can put it in a succinct way. What happens is if you track and account for the time that the product spends on the floor, and when we're classifying that, we classify it according to 3 different elements. One is the product can be in a delay mode, where no man or machine is doing something to it.
Waiting,
or it can
right?
be,
Just call it waiting.
Basically waiting. Yeah, but we call it delay.
Okay.
But the product is in delay. We're not talking. A lot of times, the thing that we've seen a lot of lean implementations is people get their frame of reference mixed up. They in one case they may be tracking a resource, in another they may be tracking the product, but there's not a consistent frame of reference. But if you keep it at the product, you'll get to all the waste. But getting back to my point, we talk about delay, and then we talk about non-conversion, which would be similar to non-value added in a lot of cases. And then we have conversion. But we track the path of the product, and we assign what type of time is being spent by that product. And once you've got that compiled, you determine where the predominant amount of time is coming from, and you make that your priority of attack. So like, for example, if it's like the typical pie chart you see, where 95% of the time that a product spends in the shop is due to delay, that's your first source, and you attack the delays, and then you attack the reasons for the delays. But it's kind of like you're not looking at waste directly. You look at the time, and then you let the time tell you what you need to do.
Okay, I think we might be saying the same thing, just in slightly different words.
It's similar. It's similar. It's similar, but to me, it's kind of like a lot of times in math, like you can have one formulation to solve a problem, and the arithmetic's real difficult. But at the same time, they have like that'll be called a primal formulation. But they also have what they call a dual formulation, and if that primal formulation is complicated, a lot of times you can create what they call a dual formulation, which is often much simpler. It converges to the same answer, only one is a little bit easier. And the thing that's the argument we make for quantum lean. It converges to the same answer, but it's a lot simpler for people to relate to, and it's also a lot more simple to apply. Because like if you're just looking at time, that's one thing. If you're looking at the 7 wastes, that's 7 things. That's kind of the difference. That's one difference.
I'd like to add one more angle to this, and it's important because a lot of practitioners and all these scholars talk about improvement organizations, processes, and so on and so forth, and they talk about lean as well. But hardly anybody talks about the cost of this improvement itself. If I am a business owner, particularly smaller business owner, I am very sensitive to the cost of improving my operations itself. If we are talking about all focused on applicability, what is easier to apply? What is going to give you faster results? That means the cost of application of improvement reduces. And what is going to result in better understanding by the employees so they can sustain that type of improvement motion. So when you look at it as a picture, including all of these elements, our approach becomes easier because it isolates one particular element being in the product that we believe is supreme to any other entity in an organization. Because that's the only link any company has with the world, meaning their market or consumers or customers. The only way customers know a company is through their product. When we say product, that translates to goods and services, obviously. And as Sean gave you an example about quantum lean, you realize that this is also very valid for non-manufacturing entities. So when we are talking about focus on an easy way, trying to get to the result and improvement level in a faster way, we believe we have proven with more than hundreds of companies, validated it to be much easier. Folks who go through our system, they remember that. The transition to them from experts or consultants to the company is much easier. We don't have to go be with them for years. We help them, they transition, now they own it. It's easier for them to implement on their own. So if you're talking to them and saying, hey, let's focus on defects, rework, transportation, waiting, inventory, all of these fronts, and you have different groups working on everything. This is like pocketed improvements by different groups and many projects. And those projects can be very costly. But when you're talking about, let's focus on time of the product throughout the system, from the moment customer is engaged until the customer receives the product. Mm-hmm. Let's talk about and see what happens to that product. Now you have a common thread throughout the organization to easily track that. And we believe from our proven records that these types of improvements cost much, much less to the organizations than trying to go after 7 wastes or 8 wastes recently added, human waste. So that's one of the angles I wanted to point out.
Got it. So what kind of, would you say that, do you have any like unique methods or tools or something that you guys are using that you would, I guess, wouldn't see in a traditional lean deployment or whatever you want to call it?
Well, and it's kind of like what I talked about earlier. It's a similar idea to value stream mapping, but we call it product path diagramming. But to me, what makes it simple, we track the product's path in terms of time through a shop. And like I was talking about before, we use 3 symbols, and one symbol is delay, one symbol is non-conversion, and another symbol is conversion. But that's all we use. We use those, 3 symbols to classify the product's experience. Now, to me, part of what makes that a lot simpler is a lot of times when people use value stream mapping, there are a whole lot of symbols going on. And to me, the other thing that happens is, as I talked about earlier, like a lot of times in lean implementations, people change their frame of reference. Like, for example, they'll be looking at the resource, they might be looking at the product. And to me, this type of mix-up of frame of references has created all kinds of other tools. Like when people create a value stream map, they want to do one type for the office, one type for production, or, also they've even created a subject in the past that didn't really take off, but it was called lean consumption. But if you approach from a quantum lean angle where you're just looking at the delay, non-conversion, conversion, it works in any situation, whether you're thinking about consumption, whether you're thinking about office, whether you're thinking about production. And so it's just a highly simplified approach. And when you only have to learn 3 symbols and you only have to learn about time, it's just people can really pick up on it very quickly, like I said.
So what happens when you have let's say you call it a delay? What was it you called it? Not a value stream map, you called it something else?
a product. Let's just call it a product path.
Product path. We have a product path, and we come to a point in the product path where there's a delay of a day because the machine, it takes a day to convert from one product to the next.
Okay.
Oh, you're referring to like changeover? Or,
so like, would you
from one order to the other order?
Are you okay with doing quick changeover, like SMED, or?
No, absolutely. Well, we understand. Let me make one thing very clear. We have practiced all of these 7 wastes, both of us, independently and together. Ron, I want to make sure that our audience understand. We are not saying they are bad. We are not saying they don't work. We are saying the way they work, the way they are practiced and implemented, are much more complicated and costly than the way we want to do with our quantum lean. We have practiced all of them. We understand all of them. We have taught all of them, for God's sake. But the reality is this. Very simple example that you bring up. Think about changeover from one order to another. If you are stopping one order or suspending it and going to another order when you change over, maybe for a reason of customer wants to have an expedite or manager has a favorite.
They want red parts instead of blue.
Well, either one.
Yeah.
We are talking about measuring that order or that product's time. If you're suspending one to the other one, what's happening to the one that you suspend? It's in delay mode. That's what we are trying to address.
Well, I guess what I'm saying is the customer ordered 10 blue parts and they also want 10 red parts, but we only have one production line. and we have to
That's
change
understood.
our paint station over from red paint to blue paint, and it currently takes us a day, to do that.
Yes, absolutely. Yeah, when that happens, the changeover, we rely on SMED. Absolutely, yes. We like SMED. Yeah. It works very well. Yeah. And it is applicable very easily. Again, from our standpoint, when you apply it, when you try to implement SMED, again, product centricity becomes much easier to do that. It's faster to implement and get the changeover.
Yeah.
So that's what we are trying to say.
Mm-hmm. Yeah. Like let me add a point to that, because the interesting thing about SMED is that if you actually take SMED and distill it down, when you use the three symbols of, delay, conversion, non-conversion, the interesting thing is you apply that technique to diagram a changeover process. It actually works completely congruent to SMED. Mm-hmm. And the neat thing is, but that's part of the simplicity. The point I want to bring up is that when you start using the three symbol method, mm-hmm. it works when you're analyzing, like when you get to the point where conversions occupy a lion's share of the time of the product, then you can use the three symbol method to analyze processes. You can use the three symbol. When I say processes, I mean like the actual work on the product. You can also use the three symbol method to actually reduce the setup time. And it really, SMED is very congruent with that. Only the nice thing is once you learn the three symbols, it's kind of like you can start practicing lean in a very comprehensive and broad way. Mm-hmm. And a lot of times people, the thing that we've seen with a lot of lean implementations is that people bring a lot of ifs, ands, or buts into it. And to me, if you can just have a very consistent approach that's very applicable across the board, it just makes things a lot easier on the people having to, execute those changes.
Got it. Awesome. Well, I mean, I think it sounds like a really interesting approach. I mean, it's, and maybe I'm not going to do it justice. You guys tell me if you disagree. What I'm hearing with the idea of what you're approaching, what I would call traditional value stream analysis with a simplified approach to identifying opportunities for improvement using three symbols, right? Delay.
That's fair.
Convergence and non-conversion or something like that.
Conversion. Yeah.
Conversion and non-conversion, right? Yeah,
so that's right. Yeah.
So, and then once you've identified those opportunities for improvement, we I assume go after them and try to improve them however we need to improve them. Is that a fair assessment?
That is correct. That's a beautiful characterization, in my opinion.
Yeah. So, I mean, it sounds like, I think, again, I don't think we're saying anything different. And, we've obviously seen, myself, I've been very successful with traditional value stream mapping over the years and reducing, throughput or increasing throughput, with incredible success. But I've also seen it with incredible failure, right? So, so I think there's a lot of what I appreciate about the continuous improvement world is, most people are open to seeing how a slightly different approach. We're all in the same team, if you will, and maybe everybody has slightly different playbooks, right? Because Toyota is going to preach 7 waste till the day they die. They're not going to stop, right? I mean, so I'm not going to say Toyota's wrong or they've been wrong for 50 years because they've been pretty successful, right? With the 7 wastes, right? So, and guys like Paul Akers and, they would argue you need nothing more than the 7 waste, that's their approach. And so I don't think, say one's wrong and one's better or anything. It's like, they're all different but we're all trying to do the same thing, right? We're trying to make the world a better place and our processes better.
Of course. I mean, number one, if people hadn't done all this lean work, we wouldn't be talking to you right now. But number two, that's a point that I like to make is that, to me, they've done amazing, great work, and Toyota is the gold standard of lean. Mm-hmm. But the thing that we bring, like I say, there's like one. I think the way we look at it, it's a formulation that can be kind of complicated, is the way I look at it. And what we're doing, we're going after the exact same thing only number one, we've seen it through experience, but it's a simpler formulation. And that's where we go for the improvement. In math, you can have two different optimization problems. One's called a primal and a dual. It's just a lot of times it can be hard to solve one way, but it can be much easier to solve the other. And we think that we offer a simpler way of going at the exact same problem. But yeah, I mean, to me, obviously all the lean work that's been done is outstanding.
Yeah. Good stuff. Guys, how can people, you've wrote a book? Is it available now or coming out or?
It's coming out on September 28th.
Okay. Well, this episode is not going to be for some time. So yeah, this episode, it'll be past September 28th. So yeah. So,
okay.
So it's, what's it called?
The book is called Quantum Lean, Taking Lean Systems to the Next Level.
Got it.
And you can buy it. You can buy it on Amazon. Yeah.
Yep. Now, do you guys have a website, or how can they best connect with you individually? Maybe social media, something like that.
The best website for us to be connected with is a nonprofit organization called Beehive Fund. So it is www.beehivefund.org. That would be the best way to communicate with us.
Okay.
And we are on the LinkedIn as well. And anybody searches our name with Quantum Lean book published by J. Ross Publications. I'm in Publishers Company. We are easily reached.
Got it. All right. Well, thanks again, guys, for coming on. I appreciate your insight, and maybe we'll have you on again down the road, and we'll hear some more success stories.
Well, thank you, Ron. Thank you for this opportunity. We are very, very, very strong fan of you. I've used your publications and books in the past. We appreciate the opportunity.
Great.
Yeah. Thanks very much for having us.
All right. Okay. Take care, guys. Thank you.
You too, Ron.
Bye-bye.
Thank you.
Thanks for listening. Whether you've been on the continuous improvement journey for many years, or perhaps you're just getting started, Gemba Academy is here to support you. And while we're best known for our more than 1,500 Lean and Six Sigma teaching and virtual tour videos, we also have a team of experienced Lean and Six Sigma practitioners available for one-on-one coaching, as well as a variety of Lean and Six Sigma certification options. To learn more and to schedule a demo, head on over to gembaacademy.com.